Hello, YouTube. This is Umo03. In the previous lesson, we had a chance to review some techniques and methods for working with dictionaries, right? We've been thinking about not only hash maps, not only hash tables, not only linked hash maps, but also now concurrent hash maps, which we studied formally in lesson 69, but had a chance to review in lesson 70. And then I also wanted to talk about pass by value, but I sort of ran out of time. So that's probably going to be the goal of this video. But what we can do is we can just try to remember and study and retain all the information that we have about data structures, right? We're getting to the end of the curriculum, and you should be leaving with a good understanding of how to compare and contrast different data structures, depending depending on the type of data that you're trying to hold and also the operations that you'd like to have available to you, right? So if you're talking about a last in, first out data structure, right? Or if you want the elements, if you want the order in which the elements were added to be the opposite of the order in which they would be returned, you'd use a stack, right? But if you wanted them to line up with each other, if you wanted it to be first in, first out, you'd consider a queue. So anyway, we can remember that an array list, or also a vector, is a list whose elements have index positions, right? And a linked list is a list whose nodes point to the next node. So even though these three classes have very, very similar methods available to them, you would say that an array list and vector are a lot more similar than an array list and linked lists are by virtue of the geometry and conceptually what's happening with the way those elements are arranged within the data structure. And then a stack is a last in, first out data structure. Remember, so you have to think about the push and the pop and the peek methods, right? And then with a queue or a concurrent linked queue, we have a first in, first out data structure. So you can either do add method to add an element to the end of the queue, pop to return and remove the first element, or pull just to return the first element without removing it from the queue. Like if you just wanted to look at the first person in the supermarket without serving them, right? And then a hash set or a linked hash set is an unordered collection of unique elements, right? You can't have any duplicates, but we said that a linked hash set is a subclass of a hash set. And then a hash map from lesson 55, or a hash table from lesson 64, or a linked hash map from lesson 68, or a concurrent hash map from lesson 69 is an unordered collection of key value pairs, right? And then we can think about the iterator types on all those data structures, right? So remember, with iterators, we talked about those in like lessons 50, 51, 52. But you can check for a next element, you can return the next element, and you can optionally remove that element that you just referred to with next from the underlying data structure. But we said that a list iterator is much stronger, right? Not only can you check for a next element and return the next element and remove the element that you just referred to with next, but you can also use the list iterator to replace elements in the underlying collection, add elements to the underlying collection, and also traverse the underlying collection in the previous order, right? Like moving from the end of the collection to the beginning of the collection, like the opposite of the next, right? You'd be going previous. And then with an enumeration, remember we said enumeration is like an iterator, but it's worse for two reasons. Number one, the method names are longer, right? Instead of saying has next, you'd have to say has more elements. Instead of saying next, you'd have to say next element. But also you can see there's no remove method, right? So we said at least 2 or 3 or 4 times in the past that an iterator has a remove method, but the enumeration does not have a remove method. So hopefully that's clear to you. So the array list gets an iterator and a list iterator, but the vector also gets an enumeration. So as far as indexed lists go, that's the functionality as far as iterators that you have available to you. And then with a linked list, you get an iterator or a list iterator, right? And then so it'd be very straightforward to call them, right? So linked list of type X, my list equals new linked list of type X, right? And then you would have code to go ahead and add elements to the linked list. And then you could either say iterator of type X, I1, and then you could either say, my list.iterator, or you would say list iterator type X, I2 equals my list.list iterator, right? But these are the two methods, the two instance methods from the linked list class that you would call to generate respectively a regular iterator or a list iterator. But one of the things that you have to remember is that if you want to use classes from the java.util package, so for example, java.util.arrays or java.util.scanner or java.util.hashmap, you need to go ahead and either import the entire package, so import java.util.star, or at least import the specific classes that you'd like to use from that package. And we said the java.util.concurrent package is a separate package. So even though it has the words java.util in it, if you wanted to use a concurrent linked queue, which we talked about in lesson 66, or a concurrent hash map, which we talked about in lesson 69, you'd have to either write import java.util.concurrent.star, or java.util.concurrent.concurrent linked queue, or java.util.concurrent.concurrent hash map. Hopefully that's clear to you, but you have to import those. Okay, so hopefully that's clear. But yeah, what we would do is we would say that a stack, which is a subclass of vector, right? Remember, stack is a subclass of vector. So anything that a vector can do, stack can technically also do, right? Vector, we think about, the get method to retrieve an element by index position. Technically, you can do those kinds of things with stacks. Okay, so stack, you also get the iterator and the list iterator and the enumeration, because the vector has those things available to us. Hopefully that's clear to you. And then with a queue, we only have an iterator, right? So we said that queue is an interface which implements the linked list class, right? So you'd say something like, remember, queue of type X, my queue equals new linked list of type X. That's how you would declare and initialize an ordinary queue. Or you could say concurrent linked queue of type X, my queue equals new concurrent linked queue of type X, because concurrent linked queue is actually a concrete class, while queue is just an interface. But either of them only have an iterator available to them. So there's no notion of adding or setting elements in a queue. You couldn't do that with an iterator, because an iterator can't do that. So a hash set and a linked hash set. Remember, linked hash set is just a subclass of hash set, and they're very similar. We talked about them, I think, in lessons like 50, what was it, like 54, and 54 was probably for hash sets, and then linked hash sets probably was 67. But both of those just have an iterator on them. And then for dictionaries, hash map, you get an iterator on the key set or an iterator on the values. Hash table, you get an iterator on the key set, iterator on the values, or an enumeration on the dictionary, which we said has the effect of enumerating on the values, right? Parsing the values out. With a linked hash map, you only get an iterator on the keys or an iterator on the values. And then with a concurrent hash map, you get all three. So you can iterate on the keys, iterate on the values, or enumerate on the dictionary, which has the effect of parsing through the values, right? And we talked about 5 different approaches in the previous video for basically parsing through the values of a dictionary. So I'd encourage you to go review that. But remember, in the previous video, we added some key value pairs to a dictionary, and we were talking about the put all method and the replace method and the get method and the size method and the is empty method, right? And the key set and the values and these iterators, right? So you want to go ahead and review those things. But the point is that if you're talking about a concurrent hash map or hash table, there's pretty much 5 different ways that you can iterate, 5 plus different ways that you can iterate through the values in the dictionary. So you should be comfortable comparing and contrasting these approaches and really using iterators to increase the functionality of your data structures and parse the elements of them, rather than just using a for loop or something like that. And then also remember, in the list iterator, remember we talked about this in the previous video, but also list iterator of type integer parser equals numbers.list iterator. So remember, just to review, we created a vector of type integer. We called it numbers. We added 5 or 6 elements to it, and we used a list iterator on it because we said that vectors have a list iterator available to them. And then we scooted to the end of the vector using the list iterator, what we just call parser.next, for however many elements there are in the list iterator, right? So if there were, for however many elements there are on the vector, right? So if there were 16 elements in the vector, then you'd go next 16 times. That'd get you to the end of the vector. But remember, we used a stack to add the elements in reverse order. So now the parser's at the end. And so what we're going to do is we're going to push elements onto the stack in the reverse order of the way they were in the vector, right? And so the stack is just going to have the elements, but it's going to be like the last element in the vector is going to be at the bottom of the stack, right? And the first element in the vector would be at the top of the stack, because that's the most recently added one if you're traversing the vector in reverse order, right? And so then if you go ahead and use the stack and you pop off the elements from the stack using this for loop, this is something we saw in the previous video where you would basically say for int p equals 0, not the case that LIFO.isEmpty, because stack is a subclass of vector and vector has an isEmpty method, or you could have just said LIFO.empty because stack has an empty method. p plus equals 1, and then you say system.out.println of leafo.pop, so stack.pop, so that returns and removes the elements from the top of the stack, which would have the effect of iterating through the vector from beginning to end. So that's why you get 2, 0, 3, 7, 10. But remember that we also use this line right here, parser.set of 400, to change any of the elements in the vector to be 400s, right? So the stack used the original elements from the vector, but while we were using the list iterator, we also modified the original vector itself to replace any even numbers with 400. So then when we use the toString method from the vector class, when we say system.out.println of numbers, it would give us this clean string representation. So it would say 400, 400, 3, 7, 400, because we said if s mod 2 equals 0, parser.set of 400. So hopefully that's clear to you, and you can go review data structures and iterators in previous videos if any of this is still unclear. What we're going to do in this video is talk about something called pass by value. So it turns out that in Java and other programming languages, right, this is not just a Java fundamental, but this happens a lot in computer programming. When you use a static method, or when you pass information into a static method, like a variable, you pass in an argument, one of the things you have to realize is that at the end of the local method, or at the end of a function call, sometimes the information or sometimes the work that happened in your static method can be lost. And so basically Java passes information by value. And so what that means is when a variable is used in a local method, like a standalone function, information at the end of the function can be lost. So basically what happened is that variables are passed into functions by copying their values rather than bringing in the actual identity of that particular variable. And that can lead to some unexpected results. So what I'm going to do, I'm just going to uncomment some code here, and we're going to have about 8 or 9 minutes to talk about some of these fundamentals. I guess I already uncommented it, so you can look down here. But what we do is we say int t equals 5. pbv.add2 of t. So you can see we're in a class called pbv right now, and presumably there's a static method that accepts one int, right? It's going to be a static method because it's called on the class itself. So it says pbv.add2 of t, and it looks like it's going to accept this 5. And so we're just going to look for a method called add2, and it's a static method that accepts an int. So it's probably this one here that we wrote directly underneath the main method. And it says attempts to add 2 to the input. So it says y plus equals 2. And then we're going to say system.out.println of t. But if you look on the console here, it just says 5. So it says t equals 5, but then we try doing like, t plus equals 2, right? Assign t to be whatever the value of t was plus 2. So 5 plus 2 is 7. But here it still says 5 when we say system.out.println of t. And so this is a little confusing, right? It seems like we should have gotten 7. And so this is an example of pass by value, where Java passes a copy of the 5 into the method, but then it technically adds 2 to the 5 to get 7, but then the 7 doesn't come back into this main method, right? The 7 is sort of discarded, right? It's like a local method call, but that information is not going to be retained. And unfortunately, t was not successfully updated. It's still going to be 5. There's 3 approaches that you can use to solve this phenomenon and to get around this. You can either keep up with an instance variable associated with an instance of a class. You can return a value rather than just using a void method, or you can use a one-dimensional array rather than using a singular value. So we're going to talk about those 3 approaches. What we're going to do is we're going to say object apple equals new PBV. So what this does, this is an example of polymorphism, right? Where we're declaring an object as an object, but we're instantiating it as a PBV. So let's look for a constructor in our PBV class that accepts no inputs, right? That's what's called a default constructor. So it says if you say PBV with empty parentheses, right, no inputs, it says this of 100. So this looks for the constructor that accepts an int and like uses value 100, right? So it would really be this stop value equals 100, right? This would be shorthand notation for this stop value equals 100 because it calls the constructor above. But it would be this stop value equals 100. So it basically assigns the instance variable value, like the name value, to 100 if you call this static method. And that's what happens here. Object apple equals new PBV, but then you have to convert it to an object that's declared as a PBV in order to use methods from the PBV class. We talked about that when we were talking about polymorphism. So you say PBV banana equals PBV apple. You can actually convert it to a PBV object. And you say system.out.println of before, and then banana.value. And then you're going to say banana.add of 2. So now we look for an instance method in the PBV PBV class called add that accepts one int, and it's going to say value equals this dot value plus y. So we're going to add whatever y is to the current value of that instance variable. So we're going to say take 100 and add 2 to it. So it says before, and then banana.value is 100. But then if we say banana.add of 2, it says system.out.println after banana.value, and we get 102. So it looks like for that instance variable, 2 was successfully added onto it, and it's still a void method, but this time we're using an instance method, right? We're using an instance method rather than just a static method. And by doing that, we're able to keep up with the adding to, right? We're able to retain that information, that work, and that's why the 100 is successfully updated to 102. So that's one approach that you have, is instead of using a static standalone method, you can use an instance of your class and just keep up with an instance variable, because that will successfully be updated, right? We said public void add event y, value equals this dot value plus y, and it was successfully added to the 100, and so the instance variable for that particular instance now has a value of 102. The other approach that you could have done is to simply return a value. So you could have said int cucumber equals 672. And so we're going to say system.out.println of before integer.toString of number, right? Or of cucumber, right? We said that this happens automatically in Java, right? This is called implicit casting, where it's like if you combine an int with a string, the int is actually going to be automatically converted to the string representation of it. So you didn't have to write integer.toString of cucumber, but that would happen by default. So you say before, and then the value of cucumber will be 672. But then what we're going to do is we're going to look for a static method in the PBV class that accepts 2 ints, right? Cucumber is an int and 8 is an int, and it's going to also return an int, right? So it's a static method called add that accepts 2 ints and returns an int. So if you scroll down, we have a method here called add, public static int add, event number, and int to add. And it's simply just going to return the sum of them. So it says return my number plus to add, right? And you can have clean documentation, right? We talked about how when you become a software engineer, it's important to have good documentation in your code to explain to stakeholders what it is that your code does, because they might not understand the actual lines, but they want to understand conceptually what it does at a high level. But this is going to basically return the sum of those two numbers. So if you say cucumber equals add of cucumber with 8, well, it's going to reassign cucumber to be 672 plus 8, which is 680. So now if you go ahead and print the result of the cucumber value, you say system.out.println of after with cucumber, you successfully get 680. So this is another solution that you have to the pass by value phenomenon. The third solution is to use a one-dimensional array. And so we're going to mix up the example a little bit. The point is that this doesn't just happen with ints. It also happens with doubles. It also happens with booleans, and it also happens with chars, right? Remember the character data type that we talked about back on like lesson 14 or 15 or 16, where we have these like one character things, right? Like an apostrophe or a dollar sign or a space or an up arrow or a lowercase u or the letter 5, right? Or the number 5, right? But that would be basically what you have going on. But the point is that the pass by value happens with booleans and characters too, not just ints and doubles. So we're going to say boolean c equals true invert of c. So we're going to look for a static method in the PBV class that accepts a boolean, right? So if you scroll down, I have a method here, public static void invert of boolean a. So it just says a equals not a, right? So if you start with you accept a true into the method, it seems like a would be converted to false, right? If you accept a false into the method, it seems like a would be converted to true, but it attempts to invert the boolean. So we're going to say invert of c. So true should become false, but then if we say system.out.println of c, it still says true here. So that's a little strange, and that's demonstrating the phenomenon of pass by value. But what you could do is use a one-dimensional array instead. So what we're going to do is we're going to create a one-dimensional array with just one element in it. It's a Boolean array with one element. So you say Boolean video game with square brackets equals just the element c. So it's just going to be technically an array, but with one element in it. It's just going to have that true value in it. And it's going to say pbv.invert of video games. This is an example of an overloaded method, because this time it's an invert. It's still called invert, but it doesn't accept a Boolean. It accepts a Boolean array. So if you scroll down, the invert method, it's a static method that accepts a Boolean array, and it's going to say a of 0 is not a of 0. So it's going to invert the Boolean value at the first element within the array. So a of 0 equals not a of 0. That's the result of the invert method if you accept a Boolean array. So then if you say system.out.println of print element of video game, well, finally we'll look at this last method that I wrote. It accepts a Boolean array and it returns the first element in it. Like what's the logic value? What's the Boolean value associated with the first element? So return a of 0. And you can see that we get false here. So it looks like the true was successfully inverted to false when we used a one-dimensional array instead of just the value itself. So we're going to be talking more about pass by value in the next video, but hopefully that was interesting to you. From Umos03, thanks for watching and please subscribe.